Okay, so now we're going to start 2.5, which is write and graph compound inequalities. So we need to go over some keywords, or and and. And statements mean that they graph towards each other. Okay, so that's what and mean. Or statements mean that they, and I said the, and I meant they, graph away from each other. So that's what's going on between the two. So if you're wondering which one's which, if you have an or statement, they should be literally pointing away from each other. Or you're going to have some situations where they point either going all right or all left. But either way you go, they have a very specific look. So what I'm going to use is the actual one for the actual paper itself instead of writing it on another separate sheet of paper. So let's look at number 1. It says a number u is less than 7 and greater than 3. Well, let's put u in the middle. U is less than 7. So less than means that 7's bigger. So we're going to put the bigger number over here. Think of a number line. When you write your inequality sentence, you have to put the bigger number to the right and the small number to the left. That's going to be a must. The inequality signs are then what has to follow. So u is less than this and greater than 3. So that means it's going to look like this because u is greater than 3. So a compound inequality means that I have two sides, a number going below it and a number going above it. So if we put 0 here, 1, 2, 3, 4, 5, 6, 7, and this is -1, -2, -3. In this case, we have two open circles, okay? So these can vary. Sometimes one's going to be greater than or less than, and one's going to be equal to. So keep in mind that right there. So I have a 3 and I have a 7. And it says that they're in between. So basically, when you graph it, it should look like that. These are open circles because it says less than and greater than. It says nothing about equal to's. So let's look at number 2. A number D is less than -2 or greater than or equal to 2. Okay, so it says the word or. So we really should have done this first. Identify and or. So the first one says D is less than -2 or D is greater than or equal to 2. So we have two different statements we're going to write there because it's an or statement. So watch what happens. We're going to put this on a number line. So here's 1, 2, here's -1, -2, and for the 2, it is greater than or equal to. So it's going to be a solid dot, and we're going to be shading up because D is greater than that. This one, it said D was less than that, but it's also an open circle. So open, and we shade down. Did you notice on both of them, I put D on the left so that we could follow the arrows to make sure we shaded the same direction that the arrow pointed? Keep that in mind when you're writing these. You have control of these. Okay. A number S is no less than -2.4 and fewer than 4.2. So the word and tells me I'm going to have a complex or a compound in this case. So for the first one, we'll go ahead and set it up in the direction it should be. We're using Okay, sorry about the dogs there, folks. Let's pick up where we left off. A number S is no less than negative 2.4 and fewer than 4.2. So what it's saying is when we write our numbers, like I was starting before the dog started barking, 2.4 is on the lower half and 4.2 is on the upper half. The inequality signs are going to tell a story. S is no less than. So that means it can't be any fewer than this. But it can be equal to. No less than means it can be equal to it. And fewer than 4.2. So that means it's also going to be a less than sign, but it says fewer than. So in this case, it's saying that we're not including the number, but the 2.4, it's no less than that number's the lower end, but I can't reach 2.4. Okay, I'm sorry, 4.2 is what I meant. So let's graph this. So the first thing we're going to do is put it on 0. And we'll just make them whole numbers and just kind of fill in around it. So -1, -2, and -3. So if I have this right here is a closed on 2.4. 2.4 is really close, folks, to your half. 4.2 is just above, and it's an open. So they're not perfect, but they're close. And we're going to shade between because it's an and statement. We shade between. Let's look at number 4. A number C is more than -4 or at most -6.5. Now, at most means I include it. So C is more than -4 or C is at most 6.5. So I'm going to skew my line over a little bit here with 0 so that we have room. So -1, -2, -3, -4. So we have -4. C is greater than that, and it's an open circle, so we're going to shade right. -5, -6, -7, and we are literally right between, but we're going to have a solid circle there, and it's going to be smaller, so we're going to shade left. Now, we have those two things. Let's look at number 5. A number C is no less than -1.5 and less than 5.3. So once again, -1.5 is our lower number. We are using C for our variable, and 5.3 is our upper. So when we actually put this together, it says no less than. So no less than means I can hit it, but I can't go any further. And then the other side just says less than. The no in this part is what's given me the reason to put the equal to sign. This one just says less than. And once again, it's an and statement. So how we're going to write this is just an inequality sign. Now, we're going to take and we're going to graph this. So I have 1, 2, 3, 4, 5, 6, 0, -1, -2, -3. So -1.5 is right here, and it is a solid. The other one is going to be 5.3, which is almost half, but not quite. So I'm going to kind of skew it there. And once again, we are shading between the two. Okay, so now we've practiced on 5 problems. Let's look at 6 through 10. So let me put that up on the overhead here. So 6 through 10. So these here are actually making you solve. So you have to do a few steps, but then everything else is the same. Folks, don't panic about this because I find this to be easier if you look at it from one step to another. And statements are very easy to find because they are wrote probably the most confusingly. You have a number on each end or a few numbers on each end, and then you have numbers in the middle. This is an and statement. So off to the side, I'm just going to say and. To do this, you just have to get everything out of the middle and leave the variable. So to do that, you're going to take and use opposite operations like we've been doing. So the opposite of subtraction is addition. So we add 3 on actually both sides to get it out. So it looks like 3 is being added in 3 spots, but this one's to clear it. These 2 are to get it on the outside. So I have 7 is less than x, which is less than or equal to 10. So that's what it should look like. So let's skew our number line here. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since we know it's an and statement, I know I'm going to be shading between the 2. 7 is going to be the open circle, 10 is the closed circle. We then shade in between. All right. So number 7 is the same thing, but we're using division. And if you look at it, we know this is an and again because of the way the signs are set up. It's all one big long continuous sentence. This is a compound one. We know we're going to divide by -5. Now remember that when we divide by a negative, it changes the inequality signs. So this is actually going to be -3 is less than or equal to g, which is less than or equal to 2. So it flipped my inequality sign. So if you need to write the word flip here, remember you are flipping the inequality signs because you're dividing by a negative. So now that you have this, now we just take and graph it. 1, 2, -1, -2, -3. So these are both closed circles, and they shade between. All right, so here's an or. Ors are very evident. They have the word or there. So those 2 that are coming up are or statements. You solve each one independently. This one's not a new task. So 8 and 9, we're just going to kind of go through real quick and graph them. So I subtract 4 across, and I get z is less than -2, or when you divide by -3, that flips my inequality sign, so z is greater than 9. So when I graph this, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, and we'll put 9 over here because we're going to run out of room. We said that it is greater than, so we have an open circle, and that's a very short shading distance, but you can kind of take it off to the side. And z is smaller than 2, and it is an open circle. So remember, both of these are open circles, and they are in their extremes on opposite sides. If you want to do it by multiples of 2, that would be fine. That would work. Number 9, same thing. You're going to take and subtract 6 across. So 2t is less than 4. And then I'm going to subtract 7 across. So I get -t is less than or equal to -5. Now this one, when I divide by 2, you're going to get t is less than 2. Or when we divide by -1, this is going to flip my inequality sign again. So I'm going to have t is greater than or equal to 5. Now we're ready to graph it. Now this one you don't have to go too far out of the way. So 0, 1, 2. We said 2 is an open circle and it's shading to the left. On 5, we are a closed circle and we are shading to the right. All right, number 10. Remember we talked about clearing fractions? Well, you don't have to do that for this one because these are both multiples of 3. So when you divide those 2 numbers by 3, they come out to be a really easy number. So let's take and work this through really quick by multiplying this group by, 1/3, which is the same as dividing it by 3. So 2x plus 8, which is less than or equal to 12. All right, now we're ready to start working on this. This is a 2-step problem. I'm going to take and subtract 8 from both sides. And I'm going to rewrite that answer up here so I have more room. So I'm going to have -16 is less than or equal to 2x, which is less than or equal to 4. Now we're going to divide everybody by +2, which does not change my sign, by the way. So -8 is less than or equal to x, which is less than or equal to 2. Now we're ready to graph it. So here is 0, 1, 2, and we said x is a closed circle. Let's see if we have enough room for this one. And we're just barely. So this right here is a closed circle, and it shades all the way in between it. And this is an and, which we did not write, but if you noticed, it looked like the ones above. All right, last problem, number 11. This one says a certain machine operator operates properly when the relative humidity H satisfies the inequality. So we have to figure out when it balances. So basically all you're doing to find the range is solving. There is no graphing to this. So negative 60 is less than or equal to 2H minus 100, because I'm going to distribute that through, which is less than or equal to 60. Now I'm going to take and add 100 to each of them. And showing the 100 in the middle so that it drops it. So this is 40 is less than or equal to 2H, which is less than or equal to, this should be 160. And then our last step is to divide it by 2. So 20 is less than or equal to H, which is less than or equal to 80. So that means the range in which you could do is 20 degrees to 80 degrees. All right, folks, that finishes our 2.5 section. And what I am going to encourage you to start your homework right away so you do not forget how to do these processes. And once again, I apologize about the dogs running through the middle of the video. Have a good day.